Hey everyone, welcome. If you're building on AWS, you've definitely run into this problem. How do you manage access securely, but with code, not a bunch of clicks in the console? Well, today, we're going to build a complete automated blueprint for granting temporary, secure permissions right from scratch. So let's dive in.
This is the big question, right? You're building an app. It needs to do stuff. Maybe read from an S3 bucket or write to a database. But just handing it a permanent, all-powerful key, that's a huge security risk. So how do we grant just enough power for just long enough and absolutely no more? That's exactly what we're going to solve today. So, the tool we're going to use for this job is AWS Identity and Access Management, or IAM. You've probably heard of it. At its heart, it's all about controlling who can do what. Now, who can be a person or, in our case, an application, and what can be literally anything from listing files to launching entire servers. IAM is the gatekeeper for your whole AWS account.
Okay, to make this super concrete, let's frame it as a mission. We've got a brand new application, and it needs to do one simple task in our AWS account. This is a classic scenario for developers, and it's the perfect way to see IAM in action from the ground up.
So here's the game plan. First, we're going to create a new IAM user. This is going to be the identity for our application. Its one and only goal in life, get a list of all S3 buckets. But, and this is absolutely key, by default, a new user in IAM has 0 permissions, nothing, nada. This is the principle of least privilege, and it's our starting line.
So let's create our user. You can run a simple command just like this one. Think of it like this. We just gave our app an ID card. It's called App User. But right now, that's all it is, an identity. It has a name, but it has no power. If we tried to use credentials for this user right now, it couldn't do anything at all.
So, how do we give our user the power it needs? Well, we're not going to attach permissions directly to it. That's the old way. Instead, we're going to forge the 2 fundamental building blocks of secure, temporary access in IAM, policies and roles.
All right, first up, the IAM policy. The easiest way to think about this is that it's a rule book. It's just a simple text document written in JSON that explicitly says which actions are allowed or denied. This document is the source of truth for all permissions.
And here's the heart of our little rulebook. You can see it's incredibly specific. The action is S3 list all my buckets, the one single permission we need. The effect is, of course, allow. And for this particular action, the resource is star, which just means it's allowed to list all buckets in the account.
Okay, next up, we've got the IAM role. I love this concept. Instead of giving that rulebook policy directly to our user, we attach it to a role. A role is like a temporary security pass, or think of it as a special hat that a trusted user can put on to gain a specific set of powers, but only for a little while.
And this difference? It is everything. It's where the real magic of this security pattern happens. A user is a permanent thing with long-term keys. You have to protect those. But a role is an ephemeral thing that provides temporary keys. So our application will use its permanent user identity for one thing and one thing only, to prove it's allowed to assume the role. Then, it uses the role's temporary credentials to do the actual work.
So how does the user get to wear the hat? Well, every role has something called a trust policy. This policy doesn't define what the role can do, but rather who can assume it. Here, we're explicitly saying that our app user is the principal, the trusted entity that's allowed to perform this STS assume role action. This is the secure handshake that connects the two.
And the best part about this whole pattern is that it doesn't matter what language you're using. Whether you're coding in Python, JavaScript, .NET, Go, whatever, the logic is exactly the same. You create a policy, you create a role with a trust policy, and you attach them. The syntax might look a little different, but the secure blueprint underneath is identical.
All right, all the pieces are on the board. We've got our user, our policy, and our role. Now it's time to put our setup to the test. We're going to see the security model work exactly as designed, which means, first, we actually have to see it fail. So what happens if our application, using just its initial user credentials, tries to list the S3 buckets directly? Boom, access denied. And you should be happy to see this. It's a good thing. It proves our user has no built-in power. The only power it has is the one we granted it, the power to ask for more power.
So, the correct way to do it is this 3-step dance. First, our application, using its user credentials, makes a call to the AWS Security Token Service, or STS. It asks to assume our role.
STS checks that trust policy, sees our app user is on the list, and then it hands back a set of temporary credentials. Now our app uses those new temporary credentials to make the call to S3.
And what's the result? Success. Using the temporary credentials it got from the role, our application now has exactly one permission in the world. S3 list all my buckets. And it gets the list it needs. Mission accomplished. It did its job without ever using a permanent, powerful key to do it. Our mission was a success. But wait, we're not done yet. In the world of automated infrastructure, the job isn't finished until you've cleaned up after yourself. Leaving orphaned IAM resources around is a recipe for clutter and, even worse, potential security holes. So a complete lifecycle means tearing it all down.
And it's easy to forget just how many little pieces we actually created. For this one simple task, it took at least 5 distinct IAM resources: the user, its access key, the policy, the role, and the connection between the policy and the role. That's a lot to keep track of, which is why an automated teardown is so important.
The cleanup process is pretty straightforward. You just do everything you did, but in reverse. We detach the policy from the role, then we delete the policy itself. We delete the role. Then we delete the user's access key. And finally, we delete the user. Every good piece of automation that creates resources should also know how to destroy them safely.
So let's just zoom out and look at the whole blueprint one more time. 1. We create our identities and permissions. 2. We link them with trust. 3. The application assumes the role to get temporary credentials. 4. It does its job with those credentials. And 5. We clean everything up. This 5-step pattern is a powerful, secure, and repeatable way to manage access for pretty much any application on AWS.
And look, this isn't just for listing S3 buckets, right? This is for CI/CD pipelines that need to deploy code. It's for data processing jobs that need temporary database access. It's for any time you need to grant temporary cross-account permissions. So the final question is, now that you have the blueprint, what are you going to build with it? Thanks for watching.